Welcome students, this is the second lecture on partial differential equations. I hope you will learn a lot about partial differential equations after watching this lecture series. In this lecture we are going to solve the linear partial differential equation. Let us start with an easy problem. Ux equals to 0. Where u is function of x and y. Here the coefficient of ux is 1 and the coefficient of uy is 0. Hence this is a first-order linear partial differential equation. Now ux is equals to 0. Implies delta u delta x equals to 0. Which implies 1 into delta u equals to 0 into delta x. Integrating both sides, we get where f of y is an arbitrary function. Finally, the solution is uxy equals to f of y. Next, the problem is uxy equals to 5. Where u is function of x and y. Here the coefficient of uxy is 1, the coefficient of uxx is 0, the coefficient of uyy is 0, the coefficient of ux is 0 and the coefficient of uy is 0. Hence this is a second-order linear partial differential equation. Now uxy equals to 5. Implies delta 2u delta x delta y equals to 5. Which implies delta delta x of delta u delta y equals to 5. Again it implies delta of delta u delta y equals to 5 into delta x. Integrating both sides, we get delta u delta y equals to 5x plus f of y. Where delta y equals to 5x into delta y plus f of y into delta y. Again, integrating both sides, we get. Finally we have the solution in the form uxy equals to 5xy plus h of y plus g of x. I hope you have learned something new in this lecture. I am looking forward to interact with you in this lecture series.